In this video, we're going to look at modeling some real-world scenarios using math. In particular, with this material, the equations we end up setting up will be rational functions. So here's an example. A ski club at a community college plans to spend $1,350 to charter a bus for a trip. The cost will be split evenly among the students who sign up for the trip. Each student will also pay $350 for food, lodging, and ski lift tickets. So we're going to determine several things with this scenario. First of all, we're going to let C of n be the total cost in dollars for n students to go on the trip. And we need to find an equation for C. So with this, basically C is the total cost of going on the trip. So as we saw in the problem, it's going to cost, and this is I should back up and say this is the total cost for everybody together, not the total cost for one person. This is the total cost for the entire group together. So the total cost is going to be the cost to charter the bus, and then it will be $350 for each person. So if we write that out in an equation, C of n would equal the bus cost plus the $350, but we need to multiply that times the number of people going on the trip. And the number of people going on the trip is given by n. So our function for that is going to be 1,350 plus the 350 times n. So that's all we need to do for that, is take the information that's given in the problem and construct it into an equation there. Now, what we will do is find a different function. Let m of n be the mean cost per student in dollars per student if n students go on the trip. Find an equation of m. Now first I want to address this word mean in case you haven't encountered that before. In math, that is a specific kind of average. So when you hear mean, you can think average. And when I say a specific kind of average, you can that's the average that people usually call the average, which is the total value of all that we're averaging divided by the number of things that we're averaging. So that's what that mean means, is that average. Alright, the next thing I want to talk about before we get to what this m of n function will be is it's asking us to find the cost per student. So now, in the first one we found the total cost for the trip organizer. Now this is the cost for one student to go on the trip, or the mean cost for a student to go on the trip. So what we need to do there is just say that m of n equals the total cost for going on the trip, and that's what we found up here in the first problem. And so it's going to be $1,350 plus your $350n, and then we need to divide that by the number of students going on the trip, which in this case is n. So that is the mean equation. Now it's a very mean equation, but now it would be good to simplify it a little bit. So what we're going to do to simplify it is distribute that n to each of the terms in the numerator, and that'll give us m of n equals 1,350 over n plus the 350. With the first one, the n didn't have anything to reduce with, but with the second term, the two n's canceled out, leaving just the 350. And so that'll be our equation that it's asking us to come up with in this example. Alright, so let's move on to another question. I moved things up so that we could get this next question on the screen. What is the mean cost per student if 30 students go? Now here, all this is asking, this is about the mean equation, not the cost equation that we came up with in the first question. And so what this is asking is what m of 30 is. What's the mean cost per student if 30 students go on the trip? So then we just plug that into our equation that we came up with, in the previous problem. So I'm just plugging that 30 in for the in slot and then punch out the math on that. When I punch that out on my calculator, I get $395. So anytime they give you a specific value for something that you've been given a variable for, that's just a matter of plugging that value in for the variable. Alright, let's look at one more problem for this scenario. Alright, so I cleared out some space to make room for this next question. I just have our mean equation there. And this question is if the ski trip will be canceled unless the minimum cost per student is $400 or less. So basically they need to get enough students to divide up the bus trip to make it worth going. So what is the minimum number of students needed to go on the trip? So basically what they're saying is they need this number, the mean, the output here, to be less than $400. Now, it's good to write out what you need here because it can get confusing which way we're talking. So we want the mean, which is m of n, to be less than or equal to $400. And the reason why I'm saying this is because it matters a great deal which direction that inequality is facing. So m of n equals this stuff here. So what I'm going to do is take this stuff on the right side of my m of n function and I'm going to plug it in for the m of n notation that I've written out there. So what that ends up looking like is the 1350 over n plus 350 needs to be less than or equal to 400. If you do it that way, your inequality will end up facing the right way. If you don't, it's really easy to double think yourself and get it facing in the wrong direction. So once you get it set up like that, what we're doing is solving a rational inequality. So this is going to be similar to solving a rational equation, but if we multiply or divide by a negative, it's going to cause that inequality symbol to flip. That won't come up in this problem, so we don't need to worry about that. We just need to get m by itself. So I'm going to start by subtracting 350 from both sides. I'm going to take the result up here. Now 1350 over n, we need that to be less than or equal to 50. To cancel out that n, what I need to do now is multiply both sides by n. That'll cancel out my denominator. So the result there is that we need 1350 to be less than or equal to 50n. Now we can divide both sides by 50. And that's going to give me, you don't want to get ahead of yourself and flip things around. So try to keep it so that each side is where it's at. Because of the inequality, you can get yourself mixed up if you try to flip too much at once. So that gives me 27 is less than or equal to n, just bringing the inequality sign and the two sides of the inequality sign straight down. Now that I have the n by itself, if I want to put that on the left, then the same part of the symbol needs to be facing it. So the bigger side of the symbol needs to stay facing the n, and we get n greater than or equal to 27. So what that means is at least 27 students need to go on the trip. So if less than 27 students sign up, it's going to get canceled. So go out and recruit your friends. Alright, let's move on to a new scenario. Kind of similar, kind of different. Alright, before we get into a full-fledged example, I wanted to go over something to make sure you're tracking with me on how to determine something. So let's say we have Tommy, he's driving 40 miles per hour because he has his cruise control set. How long will it take him to drive at 76 miles? So I just wanted to make sure you knew kind of the formula for determining this. So the time it takes you to drive a distance is equal to the miles divided by the rate, or the miles per hour. So in this case, what we would want to do is take the 76 divided by 40, which gives us 1.9 hours. So that's how we're going to use that configuration in the example we're about to do. So to figure out how long it takes you to get somewhere, you take the number of miles divided by the rate. If that's something that is hard for you to remember, you could always make the numbers easier to work with. So just to kind of sort it out in your head. So if you made this an 80, then if you're driving 40 miles an hour, how long would it take you to drive 80 miles? Well, that's 2 hours. And so how did you get that? You divided the 80 by 40. So that's kind of a way to talk yourself into the right answer, is make the numbers more understandable, and then use that to work backward into what the formula would be. Okay, so here's our scenario. A student plans to drive at night from City A, State A, to City B, State B. He will drive 256 miles in State A, then 410 miles in State B. The speed limit is 60 miles an hour in State A and 55 miles an hour in State B. So then our first problem will be, let T of V be the driving time in hours if the student drives V miles per hour above the speed limit. Find an equation of T. Now, I want to say for the record, this bugs me that we're going to write an equation that allows for driving above the speed limit. That is unacceptable. But let's just go ahead and do what the problem asks us to do, I guess. So first of all, let me draw a diagram to explain the scenario. So basically, we're going to have two very square states. One of them is State A, and one of them is State B. And inside State A, you have a city named A. It's kind of like Kansas City, Kansas. And then in State B, you have a city named B. Alright, now the distance we want to drive from one to the other, this may or may not be to scale. The distance that's going to be driven in State A is 257 miles. And that's going to be driven at 60 miles per hour. And then the distance for State B is going to be 410 miles. And the rate is, well, the speed limit, miles per hour. Okay, 55 miles per hour. So that's all of the information there about the states. So basically, if we're always going to go V miles per hour above the speed limit, then we're going to be driving a different speed in State A than State B. So that complicates things a little bit, but not too bad. So basically, our T of V is the total time it takes to be on the trip. So we're going to use this formula that we talked about before, but we need to use it twice, once for what's going on in State A and once for what's going on in State B. So in other words, our T of V needs to equal the time in State A plus the time in State B. Now switching that into the formula, basically I'll have the miles in State A divided by the rate in State A. And then we're going to add the miles in B divided by the rate in B. Plugging in the values that were given to us in the problem, we have that's going to be 256, 257, and we don't want to put that that's over 60 because we have to work in this variable of going V miles an hour above the speed limit. So what we need to do is do 60 plus V for that speeding variable. And then we're going to add to that the miles in State B, which is 410, and divide that by the speed limit plus V, which is kind of ridiculous. But that's going to be our T of V equation. Okay, the time it takes is going to be the time it takes in each state, which is given by the miles divided by the rate in each state. Okay, so I cleared all that out except the equation that we came up with for our next question. By how much would he have to exceed the speed limit for the driving time to be 10 hours? This is just an unacceptable idea. Okay, so anyways, this the 10 hours would be our driving time. So we're going to take that and substitute it in for T of V because T of V is represents driving time. So we get the equation the right side there equal to 10. So all I did was put the t of v value on the right because it feels a little bit more normal. Alright, so in the past, how we solved these rational equations that had multiple variables was we would first determine the LCD and get a common denominator. These two denominators don't have anything in common as factors, so our LCD is going to be the combination of the two of them. 60 plus v times 55 plus v. And now we need to get a common denominator for each of the terms. Well, for the first term, what it's missing is the 55 plus v. So we need to multiply top and bottom by 55 plus v. Since the bottom is made up of multiple terms, we also need to surround those in parentheses. Plus, what's missing in the second guy is the 60 plus v. So I'm going to multiply that in top and bottom. On the right side, the 10 doesn't have any of the denominator. It has a denominator of 1, so it's missing all the parts it needs. So we need to multiply by the full LCD top and bottom. Now, once we have a common denominator, that means a couple things. One, I can go ahead and add my numerators. So over here on the left, I can go ahead and work on adding those numerators. The other thing it means is that I can multiply both sides by my LCD to clear out the fact that I have a denominator. So as far as the addition of my two fractions on the left goes, I'm going to start by combining them into one fraction over one denominator, and I'm also going to distribute into the binomials as I do that. For the first one, that gives me 14,135 plus 256v. For the second one, it gives me 24,600 plus 410v, and that is all going to be over my LCD. Alright, and then on the left, what I'm going to do, on the right, what I'm going to do is start working on multiplying out what's going on there as well. I'm first going to multiply these two binomials together. After I get those multiplied together, I will, in another step, distribute the 10. Alright, so that gives me 10 times v squared plus 115v plus 3,300. And that's still over my LCD. Now I'm ready to get rid of this denominator. So I can do that by multiplying both sides by the LCD. Because now, since we have the same denominator everywhere, it'll just cancel it all out in one fell swoop. So I'm going to scroll this up so we can continue to work. So here, the LCD on the left cancels with the LCD that we multiplied in, leaving me with just what's in the numerators at this point. Alright, so that leaves me with what's in the numerators there. I'm going to combine like terms, combine the constants, and then I can also combine the v terms. On the right, I'm going to distribute my 10. On the left, that gives me 667v plus 38,735. And on the right, I get 10v squared plus 1150v plus 33,000. Now what I want to do, since this is a quadratic equation, and I know it's a quadratic equation because I have a squared term, I want to get it all equal to 0. And once I get it equal to 0, I'm going to try to factor it. If it doesn't factor, I'm going to resort to the quadratic formula. I'm not going to show out all the steps for that, but getting it equal to 0 gives me 10v squared plus 483v minus 5,735. So if you want to go ahead and pause the video to make sure you can get to that yourself, I encourage you to do so. And then factoring wise, this does not factor. With numbers this large, honestly, I wouldn't even try to factor it. I would just go straight to the quadratic formula because it's going to be more efficient than trying to figure out the right factors. So resorting to the quadratic formula, I'm not going to grind through all the steps, but when you do it, you can get down to negative 483 plus or minus the square root of 462,689, all of that divided by 20. Now, we do have a plus or minus here, which will give us two values. But since our V stands for how much we're speeding by, we only want the positive value. The negative value wouldn't make sense as a speeding value. Because of that, I'm not even going to try to calculate it. Calculating this out to a decimal pace gives you approximately 9.86 miles per hour. So in order to get there in 10 hours, this dude needs to go around 10 miles an hour over the speed limit. This is not a bad choice. This is not a good choice. Don't be this student. But that's the math to figure out how much you have to speed by to get somewhere in a specific amount of time. So anyways, go ahead and give some of these a try on your own. Let me know if you run into any problems with them.